You know that feeling, right? That sense that you're just buried under a mountain of information. Maybe it's some gigantic customer spreadsheet that's basically unsortable, or you've got product details scattered across 10 different files. All the good stuff is in there somewhere, but finding it feels like you're digging for treasure without a map.
And look, it's a problem we all face. How do you possibly cut through all that noise and actually use the data you have? Well, that's exactly what we're going to tackle. Together, we are going to find that map. The solution, really, is all about bringing order to that chaos. Think of it this way. Instead of a messy, sprawling pile of papers all over the floor, a database helps you build a perfectly organized library. Everything has its proper shelf, all the connections are clear, and you can find exactly what you need in seconds.
So how do we start building this library? Well, first we need to get a really clear idea of what a database actually is. We're going to lean on some great foundational concepts here, borrowing from some fantastic material out of Brunel University, London, to get right to the heart of it.
Okay, I know that sounds a little formal, but let's unpack it because the key ideas are actually pretty simple. Shared collection is a huge deal. It means lots of people can access the same up-to-date information at the same time. And logically related just means it's not a random junk drawer. Everything is organized with a clear purpose.
And this, right here, this is the real superpower. A database creates a single central source of truth. Just think about the nightmare that solves. No more having 10 different versions of the same customer list floating around, all with slightly different information. It just ends the arguments. This is the official version, period. And here's something that's just so clever. A database is self-describing. It doesn't just hold your data, it holds data about your data. It's called metadata. It's kind of like buying a new gadget that has the instruction manual built right into it, so it can always tell you what each part is and what it's for. Okay, so we've got this idea of an organized library, but what's the actual blueprint for building one? Well, for most modern databases, that blueprint is something called the relational model. So let's dive in and see how these things are actually put together. It all boils down to 5 core building blocks, and we're going to assemble them piece by piece, starting with the smallest and working our way up, so you can see exactly how it all fits together. So, at the very bottom, you have a field. That's just a single column, like a column for name or email. Then, if you take a bunch of related fields for one single thing, like all the info for one person, that's a record. We usually just call that a row. And when you put all the rows and columns together, you get the whole grid, which has the fancy name relation, but really it's just the table. Now, this next concept is like a bouncer for your data. It's called the domain. Think of it as a rule book for every single column. For example, the domain for an age column might say, hey, only numbers between 0 and 120 are allowed in here. And this is so important because it automatically stops you from putting in typos or crazy values, like an age of 200, which keeps your data clean right from the start. And that brings us to the final piece of the puzzle. A relational database isn't just one of these tables sitting by itself. No, it's a whole collection of tables that are all linked together. And that simple idea, the ability to connect different sets of information, that's where all the magic really happens. So how do we actually make those links? And for that matter, how do we make sure we can find one specific customer or one specific order in a sea of millions? Well, that's where we get into the engine of the database, the keys, the links, and the rules that make the whole thing work. To be able to uniquely identify any single row, we need a special kind of identifier, a key. Think of it like a funnel. We start really wide with what's called a super key. That's any column or set of columns that's guaranteed to be unique. Then we narrow it down to the most efficient options, the candidate keys. And from that shortlist, we pick just one to be the official undisputed ID for that row, the primary key. Now, sometimes one column just isn't enough to be unique. Take a look at this table of grades. The student ID shows up more than once, and so does the module ID. But if you look at the combination of the student ID and the module ID together, that combination is always unique. That's called a composite key, where a couple of columns team up to do the job. So we've got a primary key to uniquely identify a row in a table. How do we link two tables together? The answer is the foreign key. It's pretty simple. It's just a column in one table that points back to the primary key in another table. This is the glue. This is how you build the relationships. Okay, let's make this real. Here's a super simple customers table. You can see the customer ID column is our primary key. Every customer gets one, and it's totally unique to them. Easy enough. All right, now let's bring in the orders table. It has its own primary key, order ID, sure, but look closely at that customer ID column. That is our foreign key. It's pointing right back to the customers table we just looked at. And that foreign key is what creates the connection. It acts like a guarantee that every single order in this table belongs to a real, actual customer from the other table. This simple rule prevents what are called orphan records. You can't have an order for a customer that doesn't exist. It keeps the whole system logical and clean. Now, these powerful links are protected by two really fundamental rules. First is entity integrity, which just says a primary key can never, ever be empty. It has to exist. And second is referential integrity, which says that if you use a foreign key, its value has to match a real primary key in the linked table. Think of these as the unbreakable guardrails that keep all your data accurate and trustworthy.
Okay, wow. So we've gone on quite a journey, right? From that initial chaos of just messy data, all the way to a beautifully ordered system of linked tables. All of it powered by these clever keys and integrity rules. So now, let's bring it all home and see how this shows up in the real world. Because these ideas, as abstract as they might seem, are working behind the scenes in your life constantly. The way your phone links the contact's name to their phone number, that's a relational database. The way Amazon knows every item in your shopping cart, database. Even how Netflix figures out exactly what show to recommend to you next, you guessed it. It's all powered by these exact same principles.
And when you step back, you start to realize that these simple ideas, structure, unique identifiers, and rules, they're the invisible engine behind so much of our modern digital world. It really just goes to show how absolutely vital good data management is.
So here's a thought I want to leave you with. The next time you're using your favorite app, just for a second, try to imagine its hidden library. What do you think the tables are? What are the keys that are linking them all together? And what about in your own life's data? What's your primary key, your email address, your phone number? Once you start looking for it, you'll begin to see the elegant code sitting just underneath all the chaos.